recording. It says that, all right, so this is question number 3. Question number 3 says the diagram below shows triangle PQR in which angle QPR is 62 degrees. So we can see that that's angle P. Angle PQR is 90 degrees and PR is 11 centimeters. We're to calculate the size of angle PRQ. So essentially we're being asked to find this angle here. All right, it's not difficult. Why? Because if I know two angles in a triangle and I wish to find the third angle, it's simple. The 3 angles in a triangle must add up to 180 degrees. So it means that the third angle, which is angle PQR, must be equal to 180 minus the sum of the other 2 angles, which is 62 plus 90 degrees. So everything here is in degrees. 3 angles add up to 180. If you know 2 to find the other one, simply add up the 2 you know and take it away from 180 to get the third one. So this is 180 degrees minus 152 degree. So this angle here, look as if it's equal to 28 degrees. So this angle here is equal to 28 degrees. We didn't have to do anything special to find it. Then we're asked to find the length of the side RQ. Find the length of the side RQ. All right, so if I'm using, let us say, using my 62 degree angle, this side is, let's call it X. It's in front of the angle, so it is opposite. The 11 is in front of the right angle, so it's the hypotenuse. And so the side that has no value there, the side that I don't need to find, this would be the side that is adjacent to the angle 62 degrees. So the 2 sides I'm dealing with are the side X and the hypotenuse. X is opposite to the angle, which is 62 degrees. So I'm going to ask myself, which trig ratio includes opposite and hypotenuse? And the simple answer there is sine. So I'm going to say sine is equal to opposite over hypotenuse. Then I'm going to say the sine of the 62 degrees is equal to opposite X over hypotenuse, which is 11. If I have 1 fraction is equal to 1 fraction, I would cross multiply. So X, which is RQ, is equal to 11 times the sine of the sine of 62 degrees. So RQ is equal to, so that is 11 sine 62 degrees. All right, hoping my thing is on the correct setting. And this is 9.71. And let's double check the units. The units are centimeter, or the unit is centimeters. All right, so let's see what's next. All right, B. B says the diagram below shows 3 triangles, X, Y, and Z on a square grid. All right, let's turn the page. All right, we're told that triangle X is mapped onto triangle Y by a reflection. State the equation of the mirror line. So we have to go back to triangle X is mapped onto triangle Y by a reflection for to state the equation of the mirror line. So let's go back to the diagram. Look at triangle X and Y. Well, the middle line, the mirror line is always in the dead middle between the two shapes. And obviously, looking at this, we can see that this is the x-axis, which is the line y is equal to 0, is in the dead middle between x and y. So my mirror line is the line, is the x-axis, which is the line y is equal to 0. So to answer this question, the mirror line, if I want triangle X, so is mapped onto triangle Y by a reflection in the line y is equal to 0, which is the x-axis. All right. I says describe fully the transformation which maps X onto which maps triangle X onto triangle Z. So let's go back and see which transformation is going to map X to Z. All right, this looked to me like it's a rotation. All right. Well, my first clue was this vertical line here became horizontal, and that happens in a 90-degree rotation. So, and it's the direction of the rotation is this direction, which is what? Clockwise. It's a clockwise rotation. So let's answer the question. Describe fully the transformation which maps triangle X to triangle Z. So triangle X is mapped to triangle Z by an anti-clockwise rotation of 90 degrees about the origin about the origin. You can stop it like that if you want. You could say about the origin and center. All right, this says on the diagram on page 10, translate triangle Y using the vector -7, 1, label its image B. All right, so let's do this translation. We're to translate triangle Y using the vector -7, 1. So let's go on to that. We're going to translate triangle Y using the vector -7, 1. So where is Y? This is Y here. All right, so when the translation vector is -7, 1. Now the -7, sorry. The -7, 1 is telling you how to move the shape. The -7 at the top is telling you how to move the shape horizontally, and the 1 at the bottom is telling you how to move the shape vertically. So how do we translate a shape? We do it one vertex at a time. So there are 3 vertices here, here, and here. Now, each of these vertices, each vertex is going to move the same distance, the same direction. And this is saying the translation vector -7, 1 is saying move it 7 units to the left. So if I do that, 1, 2, 3, 4, 5, 6, 7 units, and 1 unit down, that will bring me here. So this would be the new position of that vertex. All right, so that new position is what? -7, -3. So this is my new position. All right, all of them going to move the same distance, the same direction. 1, 2, 3, 4, 5, 6, 7, 1. That's the new position of the next vertex. So that is -1, -3. All right, so. And the third one, all right, once you have any smarts at all, you'd know that it should end up here. Move it 7 units to the left and 1 unit down. Once you have moved all 3 vertices, you just need to use your ruler now to connect them. Your ruler and your pencil to connect them. All right, and as I believe we're told after we move it, we're to label the shape B. All right, so let's see what's next. All right. IV, the last part of the question, it says on the diagram on page 10, we're to enlarge triangle X about the center C, which is the origin, and the scale factor is +1/2. And we're to label its image W. So we're going to enlarge X, center the origin, scale factor 1/2. So we're enlarging X, center the origin, and scale factor 1/2. Guys, in an enlargement, the distance from the center to the image is K times the distance from the center to the object. So K is 1/2. So whatever is the distance from the center to the object, which is X, the distance to the image is going to be half that. So from the center to that first vertex, it's 2 units. So since the scale factor is 1/2, the distance to the image is 1/2 that. The distance from the center now to this vertex here is 6 units right and 2 units up. If we halve that, it's going to be 3 units right, 1 unit up. So that's going to be the new position for this vertex here, over here. And now we just need to find the image of this last vertex here. The distance from the center to that vertex is 4 units to the right, 4 units up. If you halve that, it's going to be 2 units right, 2 units up. This is the new image of that point. All right. So, and again, everybody should know if the scale factor is less than 1, the shape is actually going to shrink. So once you have moved all 3 vertices, you just need to connect them and you will have your enlargement. And this now we're supposed to call W. And that is what I believe is would be the end of the question.